All right, great. Well, remember when we were talking about partial recursive functions and we were talking about programming languages with for loops and while loops, we noticed, gee, once you have while loops around, the program might not halt. The same thing can happen in the lambda calculus. Suppose I take the string lambda x.xx, which remember says, take the following string, whatever it is, and make 2 copies. Well, let's suppose I apply it to itself. Lambda x.xx applied to lambda x.xx. Well, we take that first thing, it says, look for the following string, and plug it in everywhere I have a copy of x. But that produces lambda x.xx followed by lambda x.xx, which is the same thing we had before. If we do the same thing again, well, we'll get the same thing again. So this is a string, or rather an application of one string to the other, that never settles down. We keep plugging in something into the lambda, but the thing we're plugging in has a lambda, and it reproduces the same thing we had before. So this is a lot like this exercise that sometimes you get in intro programming courses about come up with a program which prints out its own source code. It's also a bit like a self-reproducing string. In fact, you could even say that one of these x's is kind of acting like a ribosome, and the other x's is kind of acting like the RNA, and the ribosome X is acting on the RNA X, and it's producing itself again. It's like self-reproduction in the cell. So we could ask then, when will an expression in the lambda calculus settle down? That's like asking whether a program will halt or not. Well, guess what? That can be hard to tell, as we will see soon.